So here I want to go through solving a triangle here, and this is a really special case. And kind of going to start this like any solving a triangle problem here, where when we're given a triangle here, in this case XYZ, I want to draw it in a way that is helpful for me. So first of all, I notice that I'm given two sides and an angle. So I worry about the situation where it's two sides and an angle outside of that, because that's a situation we have to check to see how many triangles it actually creates. Because there's three different situations where we could have zero triangles, like those information doesn't create a triangle, or it creates one triangle and each value has only one value, like each angle has one value, each side has one value, or we have this situation where these three pieces of information can be true about two separate triangles that look different. So when we go through this, I'm going to draw first. I usually like to put my angle here, which is Y, at the bottom left. So I'm calling this big Y, and this is 30 degrees. Then anytime that I'm given a lowercase letter, I know that's the projection or the opposite side of the uppercase letter angle that I'm given. So in this case here, I know that the opposite side here is 10. And now I want you to understand that this first sketch, I'm going to do a couple throughout this, is not to scale. So obviously these two side lengths look kind of the same, but one of them is going to be 16 and one of them is going to be 10. So I'm going to call this bottom right angle here Z, because again, it projects to side Z here, which is 16. And again, I like to put these values in these specific spots because in this situation, we do have a side angle, meaning we're given two sides and an angle that's not between them. And so we have to do what we call, or what I'm calling, a height test to figure out how many triangles we actually get. So to do that, I need to find the height. And since I've set this up in this way, it's really easy to find the height because I can kind of think of this by cutting this down here to find the height here as a right triangle. And so now this right triangle here that I'm using to help me is not one of the triangles that we're creating. It's just to show me what the height is. And I should be able to see here that because I've created this right triangle to find the height, I can use SOHCAHTOA to find what the height is equal to. And so to do that, I know that sine of an angle is equal to its opposite, which in this case is the height, over the hypotenuse of this right triangle that I've created, which is 16. So my height is just going to be equal to 16 sine of 30 when I multiply 16 by both sides. And so when I do that here, you can go ahead and plug this into a calculator, or if you know a lot about your 30, 60, 90 triangles, you're going to know that it's going to be half. So we end up getting our height, which is going to be 8. And so here is where a visual that I want to talk about is going to be helpful, in the sense that we don't know this top angle here. So because our opposite side is 10, meaning it's greater than the height, but less than the adjacent side, that's when we get the two triangles here. And I'm going to kind of show an image that will help us, and then I'll kind of fly back to where we were at. But basically, what you can see here is that we have two different triangles, and I'm going to go ahead and talk about the first one here in green, this outer triangle that I have, because again, the angle here is 30 that we were given. This top side is 16 and the opposite side is 10. So there's going to be a triangle that is created like this here. And like I said earlier with the height, right, I found the height was 8. And if I were to swing this far side, this side that's equal to 10, if I were to take this side right here and kind of swing it this direction here, like it would be too long at all of these different points until we got to this part right here. And so let me just erase these. So what I see here is that there is a second triangle that is created by the information that we were originally given. This orange triangle that I've outlined still has an angle of 30. The adjacent side is still 16. And then the opposite side is still 10. But what you notice is that top angle, in this case, again, because of this picture that I took, angle C, it's different. because there's the skinny one that has a tiny angle at the top there, or the bigger outside one that has this big wide angle. So there are technically two separate triangles that are created with the three pieces of information we were given. And we're going to again come back to this image here a couple of times to help understand this. But the general idea here is hopefully you can kind of see that when I have an angle of 30, an adjacent side of 16, and an opposite side of 10, we can see that it creates two different triangles. Okay, so I'm now going to go ahead and sketch the two triangles that it creates. And again, not really to scale necessarily. And know that I'm not cutting this purple triangle. I'm not like cutting it down the middle and saying, this is one triangle and this is another. Not what I'm doing. What I'm doing here is I am showing the, long, skinny, dark blue triangle here and then the total outside triangle. And we'll go ahead and use, and not perfect to scale, but at least a semi-good image here where we got angle of 30, side length of 16, and opposite of 10. And again, we got y, z, and x. Now the second triangle here, I'll go ahead and do in red, is that kind of skinnier one where still 16, 10, and 30 here, still y, z, and x. But obviously these are two different triangles, given the information we started with. Once we've kind of created this, now we can kind of start working to find some of these angles or side lengths. And I'm always going to start by finding this bottom right angle here, which I'm going to call this first triangle the green one, my first triangle, and then the red one I'm going to call my second triangle, so that I can differentiate the different like x angles and z angles, because they are going to be different. So first one for z1 here, I'm just going to use the law of sines. So I take sine of z over z is equal to sine of 30 over 10. And then I'm just going to start plugging this into a calculator, right? So I multiply 16 to both sides, which gives me 16 sine 30 over 10. And then to get this angle by itself, I'm going to take the inverse sine of both sides. 16 sine 30 over 10. And now I'm going to take a second to plug this into a calculator to get my first angle, or solve for my first angle. So 16 sine 30 divided by 10. And that gives me an angle of about 53.13. So there's my first, actually let's do this, measure of angle Z. So there's my first solved angle here. And now what I want to do is I, again, want to kind of compare these two triangles, the green one and the red one. And this is going to be the last time I compare them, and then I'm just going to solve them completely separately. But basically, if I tried to use the law of sines to find Z2 on this one here, what you'll see is I take okay, hey, sine of Z2 over 16 equals sine of 30 over 10. And you see that it's the exact same as this. And when I go through all the math and everything, my calculator spits out 53.13, which this is obviously not, because it's greater than 90 degrees. And so we can't really use the law of sines with this, because when we are solving with our calculator, even though technically we get two answers from this math problem that we created, our calculator can only spit out one of them. And again, just to get a little bit probably too deep in the math here, technically the idea here is, if you think about the unit circle, right? When I do the inverse sine here of something, I'm plugging in a y value. In this case, it was 0.8 or something like that. And it's telling me the angle. But on the unit circle, there are actually two spots where the y value is 0.8. And so our calculator spits out the smaller one here, and we're just going to have to solve to find the bigger one. So again, maybe a little bit too much. I don't mean to be confusing, but that's just kind of why we have to reference these two triangles as opposed to just plugging stuff into a calculator, because our calculator can only spit out one answer. Okay, so last time I'm going to reference this image here, though, and the idea here is I know that, again, this was Z. Z1 here was 53.13. And basically, this light blue triangle, which is not really used a ton, is going to help us find our Z2. This should be in red, actually. Our Z2. Because the idea here is that this light blue triangle here, the sides of this are the same, right? Because it's just that same side that we swung across. And if both of these side lengths are 10, well, that means that both of these angles have to be the same, 53.13. And so from here, if we know that this little angle is 53.13, then to find Z2, or this big red angle, I just take 180 and I subtract 53.13. And so the key thing that I want you to remember here when you're going through these problems is that the first angle that we find with the law of sines is supplementary to its other version, right? So in this case here, if Z1 is 53.13, then I know that Z2, when I subtract that from 180, is 126.87. So Z2 here is equal to 180 minus 53.13, which is approximately 126.87. So that's a measure of angle Z2 here. And now that I've used that image to kind of help me find Z1 and Z2, now I can just solve the rest of these triangles separately. So if I know that this is 53.13, then to find angle X1, I'm just going to subtract 30 and 53.13 from 180. And that will give me my final angle, which in this case, again, I'm calling X1. So measure of angle X1. Remember, I'm rounding things, so I'm using these little squiggly lines to show. And if I wanted to find my final side length for my green triangle here, now I'm going to use the law of sines one more time. And so to do that, I'm going to say x over sine of 96.87 is equal to, and what I originally was given is my y value, so I'm going to do 10 over sine of 30. And so to find my x1, it's going to be 10 times sine of 96.87. Divide that by sine of 30. That should give me my final value here. So plug this into a calculator really quick. 96.87 divided by sine of 30. And I get approximately 19.86. And so if I double check, does that make sense here? So again, if this angle is 96.87, that's the biggest angle, and my side length being 19.86, it's the biggest side. That makes sense. And so that is all three pieces of information for my green triangle. I'm going to wrap up the red triangle by doing the same thing, where to find measurement of angle X2, I'm going to take 180 and subtract 126.87, and I'm going to subtract 30. And it gives me 23.13. That's my X2. And then to find my side length of X2, I'm going to use the law of sines one last time. 23.13 equals 10 over sine of 30. So X2 equals 10 sine 23.13. And now I'm just doing algebra here. So if you kind of get this, you can be done with the video here. I just want to kind of wrap it up to make sure that we have all of the values for solving both of these. And divide by sine of 30. And we should get our final value here of 7.85-ish. And again, I'm hoping I didn't fat finger any values there. But again, that kind of makes sense because X2 being 23 degrees-ish means that it's projecting to the smallest side, so 7.85 makes sense. And that's kind of how you go through a side-side angle and solve both of the triangles.